Alright, so hydrated zinc sulfate gives off water when it is heated. A student does an experiment to determine the value of X in zinc sulfate dot XH2O. Okay, so Hajra, what is this? This is the formula of a crystal. Okay, so when we talk about a crystal, every crystal will have something that is known as water of crystallization. What is water of crystallization? Water of crystallization is when water is chemically bonded inside the crystal. So, for example, zinc sulfate will be chemically bonded. It's not just that zinc sulfate is dissolved in water, it has a chemical bond with the water. Okay. So, if you want a crystal, the crystal should have some water of crystallization. Okay. If there is no water inside the crystal, then it's not a crystal. It will be in the form of a powder. So whenever you see this zinc sulfate or copper sulfate, anything, any like salt, dot H2O. And over here with H2O, we can have different number of molecules of water. One molecule, two molecule, three molecule, four molecule. Different crystals will have different amounts. So this is whenever you see this, you will know that they're talking about a crystal and water of crystallization. So X has a certain value. It's always in whole numbers, 1, 2, 3, 4, 5. So the student weighs a sample of hydrated zinc sulfate. So first he takes the crystal. The student heats the sample of hydrated zinc sulfate. So when the student will heat the sample, what's going to happen? That this water of crystallization will evaporate. Okay. So the crystal will slowly start turning into the powder that has no water inside it. Okay. So he's going to heat the sample, and as he's going to heat the sample, the mass will decrease. Why will the mass decrease? Because the water is evaporating away. The student weighs the solid after heating. So after heating, you know that the mass of the crystal will be lesser, right? The student repeats step 2 and step 3 until the mass of solid becomes constant. So he keeps on doing this. He keeps on heating it, then weighing it, heating it, and weighing it until the mass of solid will not change anymore. Okay, so they're saying state by the student does step 4. This is to make sure that all the water has evaporated. Okay, so the principle is this, that in these questions, what do we do, Hajra? Step number 1, you take the crystal. Okay, crystal has the water molecules inside it. You heat it until all the water is gone. Once all the water is gone, now you have a powder form. So you can use this process to figure out the value for X. How can you use the process to figure out the value of X? By doing mole calculations. So let's take a look at mole calculations. In the experiment, 0.574, we have this is the formula or the equation if you want to see it. In an experiment, 0.574 gram of zinc sulfate dot XH2O is heated until the mass is constant. The mass of zinc sulfate that remains is 0.322. So they're telling you that the crystal was 0.574, and from the crystal, the when when you heat removed all the water, when all the water evaporated away, so you were left with a white powder that was 0.322. So they have given you the MR of zinc and the MR of water to make the process easy. So you don't have to calculate the molecular mass using the periodic table. They provided it to you. Step number 1. So you basically have to calculate the value of X, but not directly. The examiners will give you steps, and if you follow their steps, it becomes very easy. Number 1, you have to calculate the number of moles of zinc sulfate remaining. So you have the information in front of you. Decide on which formula you are going to use and then calculate the number of moles of zinc sulfate remaining.
Uh, to find the moles,
Yes.
uh, it would be mass upon molecular mass. So, um, 0.322 divided by 161.
And so you will
Uh,
get what will be the answer?
uh 0.002.
Good. Fine. Okay. So basically these questions are very simple in the sense that the formulas have very specific things inside it, right? Volume, moles, mass. So if you have been given mass, you know which formula to use because there's only one formula with mass. Now, they're saying calculate the mass of water given off. The mass of water that has been evaporated. This is a very simple calculation. Don't overthink it.
I think for this one it would be
Mm-hmm.
0.574
Mm-hmm.
minus
Yes. Minus 0.
0.322.
So get the like do the subtraction and get the value.
Yeah. 0.252.
Yes. Now calculate the number of moles of water given off. Now you have to find the moles of water given off.
Also, you would just divide the mass
Mm.
of water
By the
by the molecular mass.
so do that.
Oh, so it would be 0.014.
1 second. 0 point.
0.14.
Yes. Now the last thing that you have to figure out is the value of x. Now can you, okay, I'm going to give this to you just as sort of a challenge. Can you figure out how you can figure out the value of x? If you can't, it's okay. I'll tell you. It's a very simple thing that you do. And you will obviously then know in the next question exactly what to do because you do the same thing every single time. But just looking at the question, just sort of take it as a challenge. Can you figure out how we can get the now with the final value, the value of x?
Uh, I think it would be we would
Mm-hmm.
divide the
Yeah.
moles in hydrogen by the moles of zinc
Sorry, say it
sulfate.
again. The moles of
The moles of zinc sulfate.
sorry, divide the moles of what by zinc sulfate?
Water. Like both
Yeah.
of the moles, we just divide them.
Yes, you find the mole ratio. Okay. So you take the moles of water, divide them by the moles of zinc sulfate.
So it would be 7, the mole ratio.
Yes. So there you go. It will have 7 of for one in zinc sulfate crystal, there will be 7 molecules of water attached. Let's take a look at another question. 1 second. Okay, an incomplete simple equation for the preparation of ammonia in the laboratory is shown. Complete the simple equation. This is not an equation that you will study in your past papers as such. Like it's not an equation in your syllabus, but just looking at the equation and looking at the elements, can you figure out what should come in the missing blank? I'll give you a hint. You know how you figure out questions like this? Because, like I said, this is not an equation from your syllabus. So, how do you figure it out when they give you equations that you've not done before? Look at what's missing. For example, none of the products have oxygen. So, you know this product will definitely have oxygen, right? Then go through the equation. See again something that is missing or something that is not balanced. Okay, and that's how you can figure it out. Check the balancing. For example, you can see that there is no mention of oxygen in the product. So the product contains oxygen. Then it will contain something else. So why don't you try checking the balancing and see what is not balanced? Whatever element is not balanced, that is probably a part of the product.
I think it would be H2O.
Yes, good job, right? So oxygen is not a part of the product. So oxygen is definitely going to be part of this product. And you can also, if you look at the balancing, you'll notice two hydrogen are not balanced in the products. So H2O, right? This is how you figure it out. Can you give the name of the compound NH4Cl? What do you think the name will be?
Um, Ammonium chloride.
Yes, good. Calculate now, this is moles question. Calculate the volume of ammonia measured at room temperature and pressure, which forms when 1.12 grams of calcium oxide is heated with excess ammonium chloride.
Also, first you would calculate the moles of.
Hmm. Start with the moles of known. What do you know? Which in the entire equation, what do you know about? You always start with the known. What?
Also, calcium oxide.
Yes. So you start with the moles of calcium oxide. So first
So,
start there. That's the step number one.
the moles of calcium oxide would be 0.02.
Okay. So now that you found the moles of calcium oxide, what is the unknown compound? Which compound are the examiners asking you to find out about?
Uh, Ammonia.
Ammonia. So now you have to find the first step number one is find moles of known. So calcium oxide was known. Now you have to find moles of unknown. So you have to find the moles of ammonia. For that, what are you going to use? What do we always do in step number two? How do we use the moles of known to find the moles of unknown? What do we do specifically? We do mole ratio, right? That's what you do. You do mole ratio. So you know the moles of calcium oxide. Okay. Now look at the balancing. There is one calcium oxide but two ammonia. So you will do it as a ratio. One calcium oxide is equals to 2 ammonia. So the moles of calcium oxide you have already calculated. So moles of calcium oxide is equals to X. You cross multiply and you find the moles of unknown. Okay. Step number one is always find the moles of known. Step number two is always find the moles of unknown. And how do we find the moles of unknown? Always with mole ratio. So use mole ratio and figure out the moles of ammonia.
The moles of ammonia would be 0.04.
Good, very good. Now that you have the moles of ammonia, answer the question. What have they asked you in the question? To find the volume. You have the moles, now choose the formula, find the volume.
The volume of ammonia would be 960.
Are you calculating in centimeter cube? Yes, because they've asked in
Yeah.
centimeter. Perfect. Good job. Ultra well done. Okay, let's take a look at another question once again. Okay, this is similar to the question we did about water crystallization. So, a hydrated cobalt to sulfate produces water when it is heated. A student does an experiment to determine the value of X in the copper sulfate crystal. Step 1, the student weighs a sample of hydrated copper sulfate. Step 2, the student heats the sample. Step 3, the student weighs the remaining solid. Describe what else the student should do to ensure that all the water has been given off. This you can give this answer using the knowledge from the previous question that we did.
Uh, I think the student should heat heat it again and then wait again until like the mass is constant.
And perfect, good job. Okay. In an experiment, 1.405 grams of copper sulfate crystal is heated until all the water is given off. The mass of copper sulfate that remains is 0.775 grams. Determine the value of x. Solve this question exactly like we solved the last one, Hajra, but do one thing that I will check we will go over it all together. So when you solve one part, just annotate the answer on the screen, okay? And then when you solve all of it, then I'll go over the calculation.
So I just do all of the working and then
Yes. Yeah,
okay.
even if you don't have to show me the working, just write down the answer that you're getting. Okay. So solve the entire question first. Like first solve the entire question. Then just or as you solve it, you can annotate. I just want the values or the answers you're getting.
Okay. Miss, I'm not sure how to do the second one.
Okay. So you have to calculate the second one, calculate the mass of water given off.
Yeah.
Okay. Why do you not? So you have the number of moles of cobalt sulfate, right? That remain. Maybe check again. Maybe the first line was missing. That's why I couldn't figure it out. I don't know. Had I put it like this, maybe if I put it like that. Because see, you have the mass of the crystal and you have the mass of the cobalt sulfate. So you'll just subtract, right? See,
Oh
we
yeah.
have the first line one. See, we have 1.405 grams of cobalt sulfate crystal and 0.775 gram remains. So you just subtract it and you'll get the mass of water. I'm so sorry, Raja. Got disconnected. Let me reshare the screen with you. Sorry.
I was just left with the last question.
It's okay. All right. You don't have to write it. You can just do the last one and then tell me the values. It's okay.
Yeah, so the last one would be 7.
All right. So last one you got at 7. 1 second. Yes, you are right. 7 is the correct answer. Okay. Okay, Hajra, I think we'll go ahead and stop it over here for today then. Okay. And in the next class, then we will take a look at your titration calculations, which are especially in paper six, you get a lot of titration calculations. So we'll actually look at it then. We'll look over some titration calculations, we'll look at empirical formula, all of that. Okay.
Okay.
Okay. All right. Thank you so much, Hajra. I'll see you in the next class. Have a good